Hi everyone, this is Math 6. We're going to start topic 7 videos from now. Okay. So topic 7 is about solving area, surface area, and volume problems. So it's going to involve a lot of shapes, and you're going to think about finding areas for different shapes and surface areas and volumes. So the topic essential question is, how can the areas of certain shapes be found? What are the meanings of surface area and volume? And how can the surface area and volume be found? So have you ever thought about what that meant, really? So we're going to explore the concept of surface areas and volumes. We have 8 lessons in this topic, and some topic vocabularies include base, edge, face, kite, net, polyhedron, and vertex. Okay, these are essential for you to learn the concepts taught in topic 7. Okay, so here's some 3 ACT math situation. There's the STEM project. Let's review what we know. Let's get ready. Okay, so see if you can remember these vocabularies from the past. We have area, parallelogram, perpendicular, polygon, and volume. Can you match which one is the correct sentence for each one? So let's look at number 1. A triangle is an example of a 3-sided blank. What kind of blank is a triangle? Is it an area? Is it a parallelogram? Perpendicular? Polygon? It has to be a noun, right? A 3-sided something. It's a polygon. Okay, polygon is any shape that's closed and has n number of sides. Number 2, blank lines form a right angle. What are lines that form right angles called? Perpendicular. Perpendicular lines form a right angle. Okay. Blank is the number of cubic units needed to fill a solid figure. Blank is the number of cubic units needed to fill a solid figure. You need to fill it. How can we determine the measurement of how much we need to fill in a solid figure? Do we find the area, or is that a volume? It's a volume problem, right? And a blank has opposite sides that are parallel and the same length. They are parallel. They have opposite sides that are parallel, and they're the same length, which means it's a parallelogram. Okay, so please keep in mind of these definitions because they're important. We're going to learn new vocabularies in topic 7, but these should be the vocabularies that you already know. We're just reviewing. Let's look at evaluating expressions. Can you see what they represent? A is 12, B is 3, C is 4, D is 9. Can you solve for these expressions? Can you figure out the values? Okay, see if you can do it by yourself. Come back when you're ready for answers. Okay, number 5, AC means A times C. Okay, so A represents 12, C represents 4, so 12 times 4 is 48. Okay, number 6, 1/2 B means you're multiplying 1/2 times B. So 1/2 times 3 is just 3/2 or 1.5 or 1 1/2, right? So I'm gonna write 1.5 here. All right, number 7, ABD. A is 12, B is 3, D is 9. So if you multiply all of the numbers together, what do you get? You should get a nice little whole number, 324. Okay, 0.5 times A is 0.5 times 12. So basically you divide 12 in half because 0.5 is 1/2. What do you get? 6. Okay, number 9, 3/4 times AD. 12 times 9. Okay. Then that just means you multiply 3 times 12 times 9 divided by 4. What does that give you? You can simplify 4 with 12. 3 times 3 times 9 is 9 times 9, which is 81. Okay, number 10, AB plus CD. 12 times 3 plus 4 times 9, which is 36 plus 36. And that is 72. Okay, did you get them all right? Check your answers. And let's move on to multiplication. Can you find each product? These are simple questions that just checks if you can be precise. Okay, how do you multiply decimal by a whole number? You multiply 3.14 times 12, but you need to include the place values later. Okay, so first multiply this like you would whole number, 8, 2, 6, and then 314. And so you add them. And then you have 2 decimal places. So you also put 2 decimal places here. And that's going to give you 37.68. Okay. So in the same way, can you figure out all the other ones, including the fractions? So 12 must be 229. Number 13 must be 2.16. Number 14 must be 253.75. Number 15, how do you multiply fractions? You change this into an improper fraction and you get 3/2 times 1/4, and that's 3/8. Okay, and then what about this one? You also change that to improper fraction. 7/3 times 9/4 times 11/8. Then you multiply the numerators, you multiply the denominators, and then you simplify. But if the numbers are too big, and if you can simplify the things that you can with the numerators and the denominators. And so that's just gonna be 7 times 3 times 11, 231/32. And that's going to be 7 and 7/32. Okay. There. Check your answers. See if you can do this by yourself. All right, the last part of the review. Geometry. Number 17, how are parallelograms and rectangles similar and how are they different? How could you describe parallelograms and rectangles? Are they similar? Why are they different? Okay, parallelograms, like we looked at above, has opposite sides that are parallel and the same length. Do rectangles parallelograms? Yes, they both have opposite sides that are parallel and equal in length, but rectangles must have 4 right angles and parallelograms don't. It might, but it doesn't always have to be. Okay, so let's record that. Both parallelograms and rectangles have opposite sides that are parallel and equal in length. rectangles must have 4 right angles. Parallelograms may not. Okay, what about number 18? How are the formulas for the area of a rectangle and the area of a triangle alike and different? Do you know how to get the area of a rectangle? If this is the width and that's length, in order to find the area of a rectangle, you multiply width times length. What about the area of a triangle? This is base and that's height. Your area of the triangle is base times height divided by 2. Okay. So how are they similar? Or how are they different? You can multiply base and height, like length and width, right? You multiply 2 different dimensions, but the triangle, you have to divide it by 2. But rectangle, that's just it, right? So how can we record that? Let's write length L and width W. And the formula for a rectangle, A equals L times W, correspond to base B, height H. The formula for a triangle, A equals 1/2 times 1/2 BH. Okay. And then the area of a triangle is a 1/2 the area of a rectangle with the same base and height. So we're going to explore this later, but this triangle really comes from another parallelogram that has the same base and height. Okay, we'll see that later. So let's look at the next page now, language development. Let's see if we can explore some vocabulary words here. Two-dimensional figures. What are two-dimensional figures? Okay, what are the two-dimensional figures that you know? What are some types of two-dimensional figures? You have rectangle. You have a square. What else? Triangle. Parallelogram. Trapezoid. Kite. You have so many. Circles. Okay. You have so many. What are the key characteristics? What do they have in common? They're flat. Okay. Or what else? They have sides or, sides or lines that enclose them. Okay. What are parts of figures? Parts. Like what are the parts? Like sides. Okay, we got sides. And then we got angles. And then we got points or vertices. Okay. What are some measures that we have? Okay. Like we can have centimeters, meters, inches, feet. Okay. Then we got for angles, we got degrees. Okay. So if you want to draw some figures, you can draw rectangle, square, triangle, parallelogram, trapezoid, kite, circles, there. What about three-dimensional figures? What are some types of three-dimensional figures that you know? Well, we have prisms, we have pyramids, okay? And then we have cylinders, okay? And cones, okay? Prisms look like these. Key characteristics. They are 3D. What else? How do you describe that? They have sides. They have volumes. Okay, so for measuring, you can measure the area or the length of the sides, right? For two-dimensional figures. Okay, then three-dimensional figures, you also have sides. You also have vertices, like points. What else? But then you have like base, sides, and then you have like 3 dimensions, like height, and then the width and the length and the height. So you've got 3 dimensions. So measures, you can measure volumes. Okay, you can measure area or surface areas, right? So there are sides that you can get areas from, and then surface area would be the area that covers the entire surface of the figure. Okay, so these are the differences between 2 and 3-dimensional figures. Okay, and topic 7, you'll also be able to choose one project from these 4 projects. Check out the pick a project for topic 7 on Canvas. Okay, that was topic 7 intro.